Here's a question. Two scooters pass the same lamppost. In the next 1 second, red moves 4 meters and blue moves 6 meters. Who has the greater velocity? Red, blue, or are they the same? Pick your choice, and we'll reveal the correct answer soon. In this video, you'll learn the language of one-dimensional motion and how motion diagrams help you see what objects are doing over time. We'll define displacement, velocity, and acceleration, and use these ideas to reveal the correct answer to the scooter question. One-dimensional motion means the object moves along a single straight line, like a drone sliding left or right along a hallway. To describe that motion, we first need a way to talk about where the object is. Position tells you where the object is on the line. Displacement tells you how far and in which direction it moved. Displacement equals final position minus initial position. Direction matters. Once we know how far something moves, the next step is to ask how fast it moves. Average velocity is displacement divided by the time interval. If our drone's displacement is 6 meters in 2 seconds, its average velocity is 3 meters per second to the right. But motion doesn't always stay constant. Velocity itself can change. Acceleration measures how velocity changes over time. Positive acceleration speeds you up in the positive direction. Negative acceleration can slow you down or speed you up in the opposite direction. To pull all of these ideas together, we use a visual tool. A motion diagram is a picture of positions taken at equal time intervals. The spacing between dots tells you about velocity, and how that spacing changes tells you about acceleration. When spacing between positions is the same for each tick, the object's velocity is constant. No speeding up, no slowing down. With constant acceleration, the spacing grows by the same amount each second. The velocity increases uniformly. If spacing shrinks each tick, the object is slowing down. That shows a negative change in velocity over time. Let's check a real example. A runner's position every half second are equally spaced, so the runner's velocity is constant during those 2 seconds. Here is a common trap to avoid. It is thinking that a position near zero means slow. Speed is about changes in position over time, not where you are. Equal spacing means equal velocity, no matter the absolute location. So far, we have defined displacement, velocity, and acceleration, and we can read motion diagrams for constant motion. Think you've got it down? Head over to this link for a practice test and join the study streak, or stick around to learn more about the topic. Back to our pop quiz. In 1 second, blue covered more displacement than red. Since they were measured over the same time, blue's average velocity is greater. The answer is blue. Velocity includes direction. Moving left along an axis defined as positive to the right means negative displacement and negative velocity. Vertical motion is still one-dimensional. A ball thrown straight up has decreasing spacing on the way up and increasing spacing on the way down, with a nearly constant downward acceleration due to gravity. At the very top, the ball's instantaneous velocity is about 0, but the acceleration is not 0. Gravity is still acting, ready to speed the ball downward. Let's construct a motion diagram from data. With equal time steps, use the velocity at each step to set the spacing. If the velocity grows by the same amount each interval, your spacing grows by the same amount too. When comparing two objects at the same time intervals, longer displacement arrows mean greater speed, You do not need the full graph to compare. Here are the key takeaways. One dimension means motion along a straight line. Displacement is the final position minus initial position. Velocity is displacement per time and includes direction. Acceleration is change in velocity per time, visible as changing spacing in motion diagrams. Ready to quiz yourself with the content covered in this video? Check out the link in the description, where you'll find Quizlet content made just for you.